Let's look at something called integration by parts. Here's an example. Integration by parts is essentially a product rule for integrals in the following sense. Remember that when you're taking the integral of a product, you cannot, in general, just multiply the integral of each factor. That's not valid in 99% of cases. So what do we do when we're integrating a product then? Well, there are many options. Sometimes substitution is a good strategy. Based on things you've learned in the past, you might try to substitute u equals 4x or u equals 3x or something in the problem. But it turns out that strategy doesn't always work. And if you try that, you'll see that it doesn't here. Another thing we can do when we're integrating a product is to use the integration by parts formula. Now, when you first see this, it looks a little strange, and traditionally, u and v are the variables used in the formula, which I always thought was confusing because u and v look so much alike. But nonetheless, I'll stick with the tradition. And what integration by parts allows us to do is to compare the left side of the equation to our equation and then use the formula on the right to compute the integral that we're trying to do. So what I'm going to do here is I'm going to let u be the first factor of the integral and dv be the second factor of the integral. By the way, sometimes you have to switch that up and you never know which way it's going to go. So it's a little bit of a trial and error here. But watch what happens when I set u equal to 4x and dv equal to the second factor. What I can then do is differentiate the first choice of variable that I've done here, and I can integrate the second choice of variable, which I've done here. Hit pause if you need to spend some time seeing how that integral worked out. Now, after doing these calculations, we can now perform this operation here on the right to get the answer to our integral. And you'll notice I can just plug in my values of u, v, and du directly from the left side of the screen to get this. This may be a good time for you to hit pause. Now it's worth pointing out here that by choosing u and dv to be the two factors of our original integral and performing this operation, it doesn't give us an answer. What it does is it takes the original problem, which is an integral, and converts it into a new integral expression. So it doesn't actually do the integration for us directly. It just converts one integral into another integral expression. And now the question is, can we perform that integral expression easier than we could have the original integral? And in this case, that turns out to be true, as you'll see. So now let's just do a little bit of algebra here. Hit pause if you're stressing on algebra. And now I can factor the 4/3 out of the second integral. You can always factor out a constant multiplier. And then the integral of e to the 3x dx, as we've seen earlier in this problem, can be easily computed. And now what I've managed to do is get rid of the integral altogether, and that leads me to my final answer after a little bit more algebra. And now we have the antiderivative we're looking for. It's be an interesting thing to do if you have a little spare time, to hit pause here and take the derivative of the bottom expression. And it's kind of messy and you'll need the product rule. And at the end of a lot of mess, you will see this thing, the derivative of the thing on the bottom does equal the integrand on the top.